data centers, utilities plants, manufacturing sites, and waste and recycling facilities. All contain critical machinery, all could lose thousands to downtime, and all run the risk of fire. But there's one simple solution to all these problems: the FLIR A40 automated thermal camera. By the end of this video, you'll know how to use it, install it, and integrate it into your existing condition monitoring systems. So if you're looking for a way to protect your productivity, people, and profits, keep watching. It's one thing to have a solution to your problem. It's another thing entirely to utilize it. To guide you through setting up, programming, and integrating your FLIR A40 automated thermal camera is Nasim, Teledyne FLIR's application engineer for industrial automation. Welcome, Nasim.
Thank you, Jess.
Thank you. So what have we got here today?
So we've got two of the three lens variants that are available for the FLIR A40 smart sensor cameras, the 29 degrees, 51 degrees, and the 95 degrees. So out of the three, we've got two cameras here, one with wide angle 95 degrees and the 51 degrees, yes. So for this demo, we have set up these cameras, of course, as you can see, on tripods, but in our normal scenarios, we have housing and brackets where you would mount these cameras.
Okay, so you've mentioned the housing. Could you talk to us a bit more about that, please? What are the options available?
Yeah. So these cameras, they come from factory with IP66 rating.
Yeah.
So they are pretty good to be installed in most of the scenarios.
Yeah.
But in certain scenarios, for instance, in a very dusty environment, it would be a good idea to put the camera in a housing because these cameras on the lens, they have got anti-reflective coating.
Yeah.
And if you clean them a lot, then the coating goes away. And that's bad for the infrared camera, and that's bad for radiometry. So in that scenario, it would be a good practice to put the camera inside a housing. I have here a housing that's IP67 rated.
Yeah.
So that increases the IP rating of the cameras from 66 to 67. And we also have accessories like an air knife that can be attached on top of this so that you don't have to clean the window frequently. And we also have accessories like the Sunshield, or we have the U-shaped mounting brackets.
Yes, so that gives you flexibility with where you can mount it, doesn't it?
Yeah.
Yeah. Okay, and so what about the environment or operating temperature?
So the cameras, they have maximum operating temperature of 50 degrees Celsius, but if it's in a harsh environment where the temperature is even higher, so we've got accessories available that can be attached to this housing. That's a cooling jacket. So that cooling jacket can use air or water to cool the cameras for harsher environment.
Yeah. So before we connect the cameras for the demo, could you just talk us through the ports on the back here, please?
Yes. So I'll start with this part. So this is the infrared glass that you see in the middle. That's a germanium glass, the lens. Below it, the small hole, it's basically a visual camera. So the camera has infrared and a visual camera. This is used for the FLIR's MSX functionality, where you can overlap the visual and thermal.
Yeah.
At the back, we've got a focus ring. So the focus ring needs a dedicated tool.
Yes.
So because these are fixed cameras in which focus does not change, so you put the camera, you set the focus, and then you leave it. Because they are fixed cameras, you don't need the autofocus functionality. So for that reason, there's a dedicated tool that's used to change the focus. And the reason why we have this tool is because we don't want operator or anyone else to accidentally change the focus of the camera. And at the back, you see here, we have the M12 connector, which is the Ethernet connector.
Yeah.
So this Ethernet connector is also power over Ethernet. So the camera has power over Ethernet capability. So you can power the camera using the Ethernet supplies. And then what the camera also has is another connector over here that's also an M12. It's for the input-output. So the camera can also be powered using the input-output connector. And this one also has the the digital output. So the camera has got two digital output and one output to get the fault in the camera. So if there's a fault in the camera, or if the camera is powered off, or if you want to get the digital output directly from the camera, you can use this port. Now, the golden port that you see above this one, it's for the Wi-Fi connection.
Okay.
So you can connect the Wi-Fi, and technically you can give power over the output port of the camera. You can connect to the camera wirelessly. So that is also possible. The wireless connection, it can work in both server and in client mode. Next to it is the serial port. This serial port can be used to connect the camera to a pan and tilt. It works over the PLCD protocol, and the camera is itself capable to move the pan and tilt.
Thank you, Nasim. That was very informative. We're now going to show you how these cameras work. And to do that, we're going to use a live demonstration of an overheating component in one of our switchgear. If you want more information about the FLIR A40 automated thermal camera, click the link in the description. Or if you'd rather listen to a podcast, check out our previous episodes with Nasim and Crystal. So as we just mentioned, we're going to be using these FLIR A40 cameras to detect overheating electrical components in the switchgear. However, that's not the only application they can be used for. Nasim, do you want to tell everyone a bit more about where you can mount these cameras, what they're useful for?
So these cameras, as we talked about, fixed thermal cameras, they can be mounted on critical infrastructure where temperature is relevant. So it can be like grid monitoring is an important place where you can put this camera. For waste processing, recycling plant, as you mentioned initially, they have a very wide application, like wherever you have a fire hazard, where the temperature goes up and then it eventually leads to a fire. So what these cameras can do is they detect the rising temperature. That's something that we can't see with our eyes, but that's what these cameras can see. So you can detect the heat when it's going up. So an anomaly, it can be detected and it can be sent out as an alarm.
So anywhere where there's critical infrastructure, a risk of overheating or a risk of fire.
Exactly. Yeah, critical component, critical infrastructure that can be monitored. Yeah.
So could you talk to us a bit about the differences between the field of view and why someone might pick one lens over another?
That's a very good question. So basically, it's something that the customer has to decide on case-on-case basis, like what is their application, how far do they want the camera to be installed. So what you want is you want maximum number of pixels to be looking at the object that you're looking at. So what you would do is try to bring the camera as close as possible, but then you would also want to have the horizontal and the vertical field of view so that it covers everything. Basically, if you take the 95 degrees, you'll have a very wide field of view. If you take the 51 degrees, you'll have narrower. And if you take the 29 degrees, it'll be even narrower. So what you need to do is go on FLIR's website on the field of view calculator, and then you select the camera, and then you give the distance. And then it'll tell you the horizontal and the vertical field of view, and it'll also give you the instantaneous field of view. So instantaneous field of view is the size of the object that is falling on 1 pixel. So you want the hotspot to be as big on the camera so that you can get the temperature data as accurately as possible.
So in theory then, say I had like a waste or facility or recycling facility, and I wanted to look at a wide expanse of that facility, would you then go for the 95? Whereas if I was like looking at critical infrastructure, like on a grid or something where there's one component that was at risk of overheating, you'd go for a narrower field of view, is that?
Yeah, so if you take the 95-degree field of view, and if you put the camera at a high distance, let's say, in that case, what you would lose is, like, if the fire starts, if it's very small, the camera will only be able to detect it if it grows bigger. Because you have selected a wide angle, and that wide angle covers that area, but it will get the data. It will see the temperature going up, but it will not be detected accurately because that area that is heating up, it might be falling on a very small area of the pixel, and the pixel is not heating up. So for that reason, you will detect it a bit later. So if you want to do accurate measurement, as I said earlier, so you want to go with the narrow field of view. So if you have the camera closer to the object, then you can go for the wider field of view, the 95 degrees.
So show us then, how do they work? Because we've got lots of cables here. How does it all work?
So technically, as I said, this is Ethernet-based device. You connect the PoE cable, the power over Ethernet we are using here. So technically, you just need one wire coming out, and this goes into a switch. So I just connect this PoE wire into the camera, and then we have like powered on the camera. It's going into a switch, and then in order to configure the camera, we will need to connect a computer. So on the computer, the camera has a web browser.
Yes.
On the web browser, we can configure the camera. Configuration means you can put ROI, the region of interest. And on that region of interest, we can define the threshold values, the temperature threshold values, and at what value we need alarm. The camera itself, it's a smart sensor camera. The reason why we call it smart sensor is because the camera can work as a standalone device. We will need the laptop to configure the camera, but in theory, we can remove the laptop connection, and then we can use the digital output of the camera, or we can connect the camera to an industrial PLC, let's say. In that case, the camera will give out alarm to those devices whenever it will detect the overheating. So now we can go to the hands-on part, where I'll show you how to connect the camera, how to find the camera in the network, and how to set up alarms.
Excellent. If you're looking for more in-depth information about the FLIR A40, have a look at our previous episodes with Nasim and Crystal. Otherwise, click the link in the description to access product information, specs, and data sheets.
So now we have connected both of our cameras with this PoE switch, and I'll have the Ethernet cable from this PoE switch. I'll plug into my laptop. And then what we need is the FLIR IP config software. This software can be downloaded free of cost from FLIR's website. So I start the IP config software. So I have two cameras connected here. One of the camera has the correct IP configuration, and the other camera is in the DHCP mode. So what I do is I assign it a fixed IP address. So what I do is 192.168.1 dot, I can give it just anything here, 95. Click OK. It is automatically assigning the IP address, and now it has reassigned the IP address. We have the exclamation mark here, and if I refresh it, then we'll be able to see two cameras connected here. So if I click here on one of the camera, and if I click on the home button here, basically this opens the web interface. So the camera has a web interface in which you connect to the camera using the web browser of your computer. I have saved the password here for this camera in this browser, but the camera comes with a unique password that's delivered with the calibration certificate. So it's in the box, and it's a unique password that's set from the factory, so that nobody else can log in to the camera. So the web interface is starting, and what I can do in the meantime is also start the web interface for the other camera, so that you can get an idea about both the lens variant that we have. So on the left-hand side, we have the measurement tools, the image mode, the palette, the isotherms. And once you have put an ROI, the region of interest, on the right-hand side, you can set the ROI, define threshold value, and the temperature value at which you want alarm. So by default, we have a spot tool. What I'll do here is just very quickly delete this spot tool, and then to give you an idea about how to make an ROI. For instance, we want to measure the temperature here. What I do is I'll select the box tool, and in the box tool, I'll just click and drag, and then this region is selected. And the region that is selected You can see a blue triangle and a red triangle. So the red triangle is the maximum temperature pixel in this area, and the blue triangle is the minimum temperature that is being measured. So what I can do is I can make multiple boxes, multiple ROIs. So in total, it's possible to make 10 boxes and 10 spot tools. So that's the maximum value that is possible. So I'll make here another box. So cover this region, and then I'll make here another box. So for our demo, let's say 4 measurement boxes are enough. So I make here 4 boxes. What's also possible is to make a measurement mask. Measurement mask is basically a polygon. So what you can do is you can put as many points as you want and draw out a shape. So what I do here is, like, let's say, just to give you a demo, I'm making a triangle, but you can make as many points as you want and draw a shape as you like. So what you now see here is the grayed out area. That's the triangle that I made, although you see a rectangle here, but the region that will be considered, the grayed out region, is the one that will be considered. So you see the red spot and the red triangle and the green triangle moving in this area to give you an idea about what region is being considered. So on the right hand side, the measurement tools that we have set, you can do the setting over here. So the rectangle that I set, rectangle 1, 2, 3, and 4, can be seen over here. And the 5th one is the polygon. So the polygon is also visible over here. And the temperature that is being measured, it can be seen live over here as well. So what I do for this demo, let's say I make the ROI. This is the box 1. So this, for instance, this is switch 1, let's say, and then I'm interested in the maximum temperature. So what I can do here is unselect the minimum and average because I'm not interested in these values. So just the maximum temperature, and click Save Changes. And then over here, I see just the maximum temperature. And then what I can do here is set an alarm. So for instance, I can make an alarm, give it a name, define the condition. So I want the alarm on the maximum temperature, like when the temperature goes above a certain value. So it's measuring right now around 27 degrees. So I'm going to make it like 31 degrees, give a hysteresis value, a threshold time. So for how long should the temperature be above this value that the camera triggers an alarm. So let's leave it as 1000 millisecond or 1 second. And then you have the option, as I mentioned earlier, that the camera has 2 digital outputs. So you can use these 2 digital output to trigger a light or a sound alarm. So let's say I've just selected the digital output 1, and then you can define here the pulse time. So for how long you want the pulse high condition when the alarm is triggered. And then in the capture media, you have the option to capture a media of the alarm state. So it can be an image, video, or a pre-trigger video. So the image would be a JPEG file, a video would be a 5-second video recording. A pre-trigger video is approximately 8 to 10 seconds of video, which is around 4 seconds before the alarm and 4 seconds after the alarm that gets recorded. So for this demonstration, I'm just going to select the image, and then the options that you can see here that are enabled is that you can email this image. So the image can be emailed to an email address, or you can email the result. So the camera, if it's in a network, then it can send emails directly. So the camera is capable of sending email whenever an event occurs, whenever there is an alarm. Send to FTP. So it's the classical FTP server that the camera can send the image file, save the image file directly on an FTP server. Save to camera. So basically the camera has an internal memory. It can save approximately 100 images. So So what you can do here is, just for this demonstration, because we don't have a FTP or an email server set, so I'll just save in the camera memory. So I select set alarm, and now, yeah, we have this switch 1 alarm condition set, and when the temperature will go above 30 degrees Celsius, we will get an alarm. What I can also show you, a very nice tool that we have, is the delta function. So what you could also do is, as soon as I have clicked on delta, the delta tool gets enabled, and you can see it over here. So in delta, what you can do is you can select alarm condition based on the temperature value of two ROIs, two region of interest. So what I'll do here is delta name. You can set a name of the delta, so temperature between switch 1, switch 2, something like that. So what I do here is, let's say if the temperature difference between the switch 1 and switch 2, maximum temperature difference between switch 1 and switch 2 goes above 5 degrees Celsius, then I get an alarm. So switch box 1 max, and then switch box 2, let's say max, and then save changes, and then I can have an alarm based on this. So right now, both of these switches, the maximum temperature value, it's very much similar. So yeah, otherwise we can trigger an alarm based on this condition. So over here, again, just like we were able to do for a normal ROI, you can here add an alarm on this delta value, and then define that, okay, if it goes above, let's say for this demo, 5 degrees Celsius, and for more than 1 second, then you get an alarm condition. So you can set an alarm on the delta as well. Okay, so to give you a demonstration, we will be simulating heat developing in this region, and this will then trigger an alarm. So for the alarm condition, I'm just using the maximum temperature value here in this alarm. So it's set at 40 degrees Celsius. So this is 40 degrees Celsius. So when the temperature will go above 40 degrees Celsius, this will trigger an alarm. What I'll do is, for the other boxes, I'll make the values that we are seeing a bit smaller, and then we delete box 3 and 4 because we don't need them at the moment. So yes, what the camera also has is RDSP capability. So if you want, if you have an operator area where you want to send the stream that the camera is looking at, so what you can do is just grab onto the RDSP stream, and what you're seeing in the web browser, both of these are live, and over here it's got some more overlays on it in this VLC player. So this is the ROI switch 1, I changed the name here, and then over here you can see the alarm condition. So this ROI has an alarm set to it. That's the reason why you can see a bell here. And then when the alarm will go on, you will see the bell getting red. And you can see here the heat is developing. So the heat developing will eventually trigger an alarm. So you can see here it's getting hotter. Right now it's below 26 degrees Celsius, but eventually the temperature will go up and it will trigger an alarm. What the camera also has, in the meantime, while the temperature is going up, I can talk about some other options that we have over here. So the camera also has the MSX, what I talked about earlier, the overlay between thermal and visual. So I've turned on MSX, and you can see you can now make out the edges because the camera is taking both of these images and creating a fusion between thermal and visual. So this is MSX, or you can select the visual camera. So you have the visual camera, and then you have the thermal overlay, and you can see here the hotspot. So right now the hottest region is somewhere around here, and yeah. So we go back to thermal, and the camera also has isotherm functionality. So in isotherm, for instance, you can select above value. And then if I go on the right-hand side over here in the setting, I can set the temperature value and the color that I want. So if I select here, let's say 28 degrees Celsius. So anything over 28 degrees Celsius will be shown in red color. So right now it's over here, but we know that as time goes by, this region is going to get hotter, and we'll see it in the color that we have selected here. So you can make two isotherm, and then over here you can select the color palette. So the color palette, for instance, you can have black and white, or you can have, yeah, these are the color options that are available. So I'll just leave it to black and white, because with isotherm, black and white looks better. So because it's heating up very slowly, what I'm going to do here is make the temperature trigger temperature at 27 degrees Celsius. So right now it's 26.6. So as soon as it reaches 26 degrees Celsius, we will get an alarm here. Now we have an alarm. So that's what the camera is triggering an alarm. And if I go into the RTSP stream, this is what I was talking about, that you will be able to see alarm in the RTSP stream as well. So we have discussed about the alarming capability of the camera. What I wanted to show you very quickly is the temperature ranges that the camera can measure. So this camera can measure from -20 degrees Celsius to 1000 degrees Celsius in two temperature ranges. So the first temperature range is -20 to 175 degrees Celsius, and the second one is from 175 to 1000 degrees Celsius. I have shown the alarming capability, which is visible here, that the alarm is sent into the digital output of the camera, but the camera also has Modbus and Ethernet protocol, so you can also send alarm, and the temperature value that you see over here, it can be sent to a PLC directly. The option that you see over here, capture image, and when alarm state occur, the image is captured, and I have selected the option to save this image to the camera. So if I go into the library of the camera, we will see images that were captured in the alarm state, and these images are in JPEG format, and this JPEG format is FLIR Radiometric JPEG. So I can just show it to you. If I download this image from the internal memory of the camera, if I just click on this image, then this image opens like this, where you can see the overlay and you can see the ROIs. If I were to go and open this image in a FLIR analysis software, which is FLIR Resource Studio, then we will be able to see all the temperature information that is in this image. You can see here the ROIs that I made. The overlays are gone. This is a raw image with all the temperature information for all the pixels. And you can do temperature analysis later on as well. So if I make a line here and do the plot the temperature on this line, then you can see here how the temperature is on this line, and you can actively move the line and the temperature will be adjusted as you do it. To give you an idea about the different field of view in the camera, so this is the 95-degree camera that we have. So the object that we are looking at and the cameras, both of these cameras, they are at equal distance, but you will see here the difference between the two cameras, the view that you get between two cameras, between 51 degrees and 95 degrees. So this is the 51-degree camera. Look at the size of the switch box that we are able to get in this camera. And if I move here to 95 degree, look how wide the 95-degree camera can look. What I also want to show you in Research Studio software is that both of these cameras are connected to the web interface, and they are streaming in the web interface. But at the same time, what you can also do is connect with these cameras in Research Studio software and record radiometric thermal data as well. So this can be done simultaneously. So I can connect to camera. I'm connecting to one of it, and you can, it's transmitting radiometric RTSP stream into the software, and you can see this is a live image. And for all pixel, I can read temperature information from the camera, and I can also do thermal analysis, just like I showed you for a line. Here also, I can do live thermal analysis. So this is a temporal plot diagram. I can select the maximum value, and then it's showing me the maximum value on this line, and with time. It's showing in frame, but in frame you can see the maximum temperature value on this line. So this thermal analysis can be done live, or what you can also do is record. So you can record this video, and all the thermal information will be recorded using the software. So this wraps up our demo of the FLIR A40 smart sensor camera.
Thank you, Nasim. That was very instructive. Now you're ready to protect your productivity, people, and profits. However, if you do want additional pointers or advice, please do contact our sales team. Alternatively, click the link in the description or head over to tester.co.uk. If you're looking for a more in-depth discussion of the FLIR A40, then check out our previous episode with Nasim, where we talk about how the FLIR A40 can be used for early fire detection, or have a look at our episode with Crystal, in which we break down the advantages of using the FLIR A40 to maintain data center and industrial uptime. Plus, make sure you like and subscribe, as that way all future episodes will come straight to you without you having to do a single thing. So you'll never miss an important development. Okay, thank you for watching, and we'll see you next time.